Hey everyone, in this video we're focusing on the trend of, where they're asking if speed will increase or decrease. Okay? Very popular question. I actually forgot and I almost didn't showcase that for you guys. So here's the video on that, okay? In short, these are the easy points, okay? But to make it easy, you have to understand the concept behind it, okay? So here's a scenario for you guys. Let's say this is my best approach at showing a running person, okay? Let's say that this person was running towards the right, okay? So if you're thinking about the x-axis, right? Okay, we're running towards the right. So let's say you're running towards the right, okay, just to make sure that this is very logical here. Now, if I came from behind and I pushed you towards the right, okay, assuming before you fall down, would your speed increase or decrease? Would you be speeding up or slowing down? Press play whenever you're ready, okay? So if you're running towards the right and I push you to the right, would you be going faster or slower? Okay, so in this case, you would be speeding up. Okay, or in this case, your speed is increasing. Okay, and here's the logic behind it. So if you're running towards the right, your velocity will be positive because a positive velocity indicates that you're moving in a positive direction, okay? Now, me pushing you, I'm serving as the acceleration. So since I'm pushing you towards the right, my acceleration is also positive. Okay? So here's the next scenario for you guys. What if, and I'll draw it a little bit smaller here. What if you were running towards the right, okay? But then I decide to push you left. Would you be speeding up or would you be slowing down? Press play when you're ready. In this case here, you would be slowing down, or your speed is decreasing. Okay, so what's happening here is that you have a positive velocity because you're moving towards the right, but then my acceleration is moving towards the left. So actually my acceleration is negative here. Okay, so here's, I won't do all the scenarios, but here's one more scenario for you. Let's say you were running towards the left and I were to push you towards the left. Would you be speeding up or slowing down? Okay, pause and then press play whenever you're ready. In this case here, you would be speeding up. Okay, your speed is increasing. Okay, you would still be going faster because since you're going left, your velocity is negative. And since I'm pushing you towards the left, my acceleration is also negative. So my question to you here is, when do you speed up and when do you slow down? Okay. Pause, really think about that, and press play when you're ready. Okay. So the big indicators here is, you notice that you speed up whenever acceleration and velocity share the same sign. Okay. Notice how when acceleration and velocity share the same sign, you're speeding up. Now notice how when you have opposite signs or different signs, you're slowing down. And it makes sense, right? If you're having two forces go against each other, you're not going to go faster. You're actually going to go slower. And that's the logic behind it. So you can tell if something is speeding up or slowing down if you can compare two different values, your acceleration and your velocity. Okay? All you really care about is whether it's positive or negative, right? You don't need to know exactly what the value is, but if you know what the sign is, you can make a comparison. And that is what makes it very easy to do. So here we go. I'm going to start off with, I'll get to 2008, but I'll start off with 2004 here. Sorry, 2003. I covered it up. 2003. And just a reminder that this is a non-calculator question because it's number 4. So in part B, they ask you, is the speed of the particle increasing at t equals 3? Okay. So remember, if you want to know if speed is increasing or decreasing, you have to check two things. You have to check the velocity at 3. So in this case, I'm just going to plug it in. That's -1 plus e to the 1 minus 3. And then I'm going to check the acceleration. Now, the acceleration is just the derivative, which is v prime of t. And you should have done this in part A already, so I'm going to move through this pretty quickly. You should have gotten e to the 1 minus t times -1. All right? So here, I'm going to find out what the acceleration is at time t equals 3. So when I plug this in, I'm going to get e to the 1 minus 3 times -1. Okay, and I'll take care of the easier part first. This is where you kind of have to have a good idea of how numbers work. All right? So for instance, on the right-hand side here, that's e to the -2. If you remember negative exponents, that's really just a reciprocal, so 1 over e squared times -1. Now, I don't know what 1 over e squared is, but I know that it comes out positive. Times a -1, that'll come out negative. So I know the a of 3 is something negative. Okay, I don't know exactly what that value is, but I know it's negative, okay? Now, v of 3, we're going to use the same logic here, okay? V of 3 is -1 plus e to the -2. And -1 plus e to the -2 is really just the reciprocal, 1 over e squared. Okay? So, e is roughly 2.7, okay? And if you square it, you're going to get something shy of 9. So 2.7 is really close to 3. 3 squared is 9. So you have 1 over 9, right? 1 over 9 is definitely something less than 1. So I know there's going to be more negatives here than there is positives. Make sure that you guys understand that, okay? Because you don't have access to a calculator for this problem. So I know that this will come out less than 0. You really have to understand how the numbers work there, okay? So, based on these two facts, what can you really conclude, right? So notice how they're both negative, so what does that mean? Since they share the same sign, you know that the speed is increasing. So you're going to say, therefore, the speed is increasing at t equals 3. And it says, give a reason for your answer. Since v of 3 and a of 3 have the same signs. It's that easy, okay? Well, in this case, it was a little bit of algebra, right? But once you understand the concept, the rest appears to be really minor, okay? So remember, you need two pieces of information in order to get your points, right? You need to know what velocity and what the acceleration is at this time, and then you make a conclusion. I haven't looked at the scoring guideline yet, but I assume it's a 2-point question, okay? But let's take a look. 2003B. Okay. So 2003B. Oh, it was a 1-point question. Okay. We showed that acceleration came out negative and velocity came out negative. Speed is increasing since, and we wrote they share the same signs. That's fine. They wrote since v of 3 is less than 0 and a of 3 is less than 0. That's fine too. Even though it's a 1-pointer, it's an easy 1 point that you can get. Okay, let's do a couple more just to make sure that you guys are getting this here. Let's, here's one, 2011. Let me get rid of all this here so that you're not bombarded. Okay, so keep in mind that in 2011, this is a calculator active question. You notice that it's a number 1 right there, so you know it's calculator active. Go ahead and do part A. Press play if you need assistance or whenever you're done. So here it says, is the speed of the particle increasing or decreasing at t equals 5.5? So remember, if you want to know if speed is increasing or decreasing, you have to check the velocity and acceleration. So as of this point, since it's calculator active, I would probably make y1 represent your v of t on your calculator, and I would probably represent y2 as your acceleration, which is right over here. And you know, on your home screen, what you would be doing is you would do alpha trace y1 parentheses 5.5. That should give you an answer. And then y2 alpha trace y2 5.5, and that should give you an answer there. Okay, so I'm going to cheat a little bit and take a look at the scoring guidelines. 2011. Okay, 2011. So if you plugged in y1 of 5.5, you should have gotten something negative. A of 5.5 should give you something negative as well. So what's your conclusion? You know that the speed is increasing at that time. Make sure that you guys write it at that time, okay? Because in this case, they wrote velocity and acceleration have the same sign. You could have written because v of 5.5 is less than 0 and a of 5.5 is less than 0. So you actually have some flexibility there. Notice how this is a 2-point question, right? So very easy 2 points to earn. Okay. I want to show you maybe one more because the rest is really straightforward. Let me show you one where it's a little bit different. I want to say it's the first one, but let me scan through this. Yeah, let's go back to the first one. Now this one here in 2008, this one can be solved in 2 different ways, but it's the same logic, okay? So we'll do it the same way, okay? In part C here, they're asking you in the interval from 2 to 3, so somewhere in between here, okay? So we're only looking there. Is the speed of the particle increasing or decreasing? Okay, this is where you have to have some graph analysis, okay? It's still the same logic. We still need 2 pieces of information, okay? So I'm going to write it down. So somewhere in between 2 and 3, so I'm just going to say 2.5, okay? In that vicinity, so somewhere in between 2 and 3, I know that v of t is definitely negative because it's below the x-axis. It has negative values, right? Below the x-axis. What's difficult about this is we aren't given acceleration, okay? But you remember that acceleration is the derivative of velocity, okay? So you can notice here that velocity is physically increasing. Velocity is increasing. So let me write that out. V of t is increasing. So you remember that if something is increasing, that implies that its derivative is positive. Remember that the derivative of v is really a of t. So that implies that a of t is positive here. So from there, you can make your conclusion that the speed is definitely decreasing since they share different signs. Okay? That's one way about it. The other way, and it's not too often that you can do this method, but I just want to offer it to you guys. This other method is definitely easier, but I don't want to say it appears as often, okay? So because they gave us velocity, we could actually graph speed. Remember that speed is the absolute value of velocity, right? So what absolute value does is it makes everything positive, right? So anything that appears negative is going to be positive. So notice how down here and down here it's negative. So if you reflect that and turn it positive, it'll look a little bit like this. So everything in green here is really your speed, because everything below the x-axis will go upwards because you're turning everything positive. And it's very easy to see that from 2 to 3, your speed is decreasing, okay? That's to get your answer, but the justification, right, that's the tough part. You still have to mention that v of t is less than 0 and a of t is definitely positive there, okay? They have different signs. Okay, so I mean, this is definitely not the trending part. It's an outlier in that sense. But for the most part, getting those points are pretty easy, whether it's calculator or non-calculator. Okay, try it out. Let me know.